Welcome to Vectric 2025 User Group Meeting. I'm Randy Johnson. And in this session, I'm going to go over some of the tips and tricks and techniques that I use when using the box gadget, as well as creating foam inserts for small storage projects like this toolbox. When I designed this box, there were three main things I was after. One was I wanted to use extended finger joints, that is where they extend slightly beyond the side of the box to give a decorative look. I also wanted the finger joints to be equal in height. The second item I was after is I wanted to use a sliding lid as opposed to a hinge lid. And the last major item was I wanted to create a foam insert to hold the tool. This is a folding handle draw knife. I've had this for a while. My father actually gave this to me when I was 16 years old. So I've always wanted to build a nice case for it. So with that, let's hop over to VCarve and I'll show you how I use the box creator gadget to create this custom figure joint setup. So I already have a file set up here to start with, and I've imported a couple of pictures that show the sizes that I'm going to be using for this project. As I mentioned earlier, I want to have all my finger joints equal dimensions. So in this case, they're all going to be 3/4 of an inch. And I want my side height to be 3 1/4. And here's the rest of my box dimensions showing right there. Now, the thickness of this material is currently set at 5/8 of an inch. And so if you look down at the lower left, I've got a depth, which is the thickness of the material, 0.625, which is 5/8 of an inch. You set that up in your job setup or in your sheet setup. Also, I've set this up as a separate sheet. This is just a working area. See at the top here, I call it Gadget Practice. That's the name of the sheet. I have several sheets set up, and we'll take a look at those along the way. But right now, I've got a Gadget Practice sheet set up because this is where I typically just play with my design until I get it the way I want it. Now, let's hop into the gadget, which is located at the top under VCarve Pro or Aspire. And the box creator gadget is right there. If you don't have it in your list, then you can download it from the Vectric website. Opening that up, I have used this, so my dimensions are already in there. You can see I've got a width, which is along the front of the box here, of 5.75, a depth or a length here of 17. My height is 3.75. My joint width is 0.75 or 3/4 of an inch. I'm not going to use any allowance for this one. And I'm also only going to create one side and one end because that's all I need for the work I'm going to do. I will duplicate those once I modify those. I've also selected my tool already, which is a 1/4 inch end mill. I'm going to set this to a flat lid since I don't want tabs on the top. And I'm going to use the square tabs or finger joints. Goes by different names, finger joints, box joints. And then I'll click OK. And it automatically creates those two parts. It also creates a toolpath over here. And if you've not used this, it actually creates a double vector. The inner vector is actually the side itself. That's your finished part. And then what the box creator does is create a toolpath vector. And if we highlight that and look at the solid preview, you can notice that it's traveling on the line and it leaves that little dog bone fillet right there so the square tendons or the square fingers can fit together. Now, for my purposes, I do not need these vectors, so I'm going to delete those. Nor do I need this toolpath, so I'm going to delete that as well. These are just the parts that I'm interested in. Now, you saw that I put in 3 3/4 for the height. But the first thing you'll notice is that I have 3 tendons on this one and only 1 on that. So it's not matching my design, even though I put 3/4 of an inch in for the tendons. The reason for that is that if we take a look here, This is what the standard box looks like, lidded box looks like coming out of the box gadget. Now this one has more fingers on it, but the idea is you can see how the lid is lipped. So half the thickness extends above the box and then the rest of the box is below, and you've got a tabbed bottom. If I were to take and draw a rectangle at the bottom here representing that lipped lid, and that's 5/8 of an inch is the thickness of our material, and we're dividing that by 2. So 0.3125 is the thickness of our lid, or our lip. And let's take and push this right up there. That's how the lipped lid sits on top of this box. Now if we pull a dimension on that, and let's pull a vertical dimension from the bottom right here to the top of that lid, that gives us our 3.75, exactly what we wanted. However, it's not the configuration we want because we don't want the tabs on the bottom and we don't want the lid. So here's what I've come across as a simple formula that you could use to create the exact number of tenons you want, or fingers, as well as the height, understanding how this all works. Because really the only part of this box side that I want is from this line right at the top to the top of those tabs at the bottom. So to create that, let's take and move this down here temporarily, and I'll show you the formula, which is it's a real simple one. The desired box height or side height is 3.75. You add to that 2 times the material thickness, which in this case is 2 times 0.625 or 5/8 of an inch. That equals 5. That's the magic number that I use to put in for this particular box. This formula works with any height that you want for your desired side, as long as you have an odd number of fingers. So let's go back into the box gadget. And the only dimension we have to change here is we want to change the height to 5, because that's what we came across when we added these up, is this 5 right here. The other dimensions all stay the same. Let's say OK on that. Turn off our Toolpath. And we don't need these 2 vectors, so we'll delete those. We can already see that we now have our 3 fingers on one side and 2 on the other, so everything's looking better already. Now, the quick way to get rid of these tenons on the bottom, or these tabs on the bottom, is simply select the vectors, go into Node Edit, and select the nodes, hit the D key to delete those nodes. We'll go over here and do the same thing. We've now deleted the tabs along the bottom. Now we can also notice how this top tab or top finger seems wider than the rest. And that's because if we look at the nodes, we have that extra node right here. Well, it's really easy. You simply remove those top 4 nodes across the top, hit the D key, delete. Let's exit Node Edit, and let's pull some dimensions off of this one. First, let's do an overall height. And bingo, we're right at 3.75. And if we pull a height on these, you'll find that these are all 0.75, exactly what I wanted. So I now have the 2 parts I need to do the rest of the box. Okay, I don't need some of these vectors, so I'm going to clean up some of this, select those and delete those. Don't need those dimensions, delete those. Now I have my 2 main parts. Now the next step that I do is I take those and I move those, or copy, either one works, but let's go ahead and do a copy, and I'm going to go to a new sheet, and I've got a sheet set up here called Test Layout. So let's turn on that sheet. We'll select that sheet, turn off the first one, and hide it. I can now take these two parts and rotate them and position them back on my sheet. This sheet is set up the size of my tool. The tool I'm using is approximately 12 inches wide by 24 inches long. So that's the table size. So I'm going to use the entire table for this project. Also, on this, something I want to point out is that although I originally set this box gadget up using 5/8 inch material, the material of my actual project is a 1/2 inch. And the reason I'm doing that is, as you can see here, my finger joints are 5/8 of an inch long, but my 1/2 inch sides allow me for that extended finger joint design. So that's how I accomplished that. Kind of lied to the gadget, telling it what I wanted. It gave me my longer finger joint, and now I can use thinner material and achieve that extended decorative look on the finger joints. Now from here, I can modify and edit, add my slots for my top and my bottom, and my holes for my decorative nails, and any other details I want to add on this, I can add to these two parts and then duplicate these parts over. And rather than working on 4 separate parts, I just duplicate it over. The other thing is that typically, if you're going to cut this out of plywood, you probably would just set up a whole sheet of plywood here and use the existing toolpath that came out of the box gadget, and you could just cut around all of this. But since I'm cutting this out of solid wood, I'm going to pre-cut blanks for the sides of my project. And I'm also going to then just set up my toolpathing, so all it's doing is cutting out the fingers and putting the dados in. For that, I've set up another sheet dedicated just for the cutting. So let's hop over to that, go for my test. I'm going to go to my side cutting sheet, turn off that one, and let's take a look at this one. Now on this sheet, open up some layers here. I'll show you the vectors that I have set up. First off are the jig pockets and the side part. So in other words, the blue lines right there represent my blanks that I'm going to pre-cut out of solid wood, and then I'll set those inside of those pockets. Let's take a look at the 3D for a minute, and I already have my toolpath set up here as well. So the jig pockets, to think about, this is what they look like on the setup. And then inside there, I will then attach my solid pieces of wood to do my finger joints. Once I have those vectors set up, I then import my actual parts that we were using in the last layout. And a couple things I've done is I've trimmed this one down to accommodate the lid going over the top, and I've arranged them in a way with the spacing needed for the machine that I'm going to be cutting them on. I've also then added finger pocket vectors because I'm only going to cut out where the fingers need to be. So those orange lines represent the cutting for the finger joints. I'm also adding some lines for the dados as just a single vector because I'm going to cut on the line with a 1/4 inch bit, and some nail holes going in the end. So those orange vectors represent my toolpath vectors, the ones I'll be using for that, and that all lays inside of my jig. So let's take a look at some of the toolpaths over here. There's a couple things worth pointing out. Let's split this view out here. One is that I'm going to block out or kind of rough out those areas using a 1/4 inch end mill first. Now you could profile it around maybe in one cut, but I've just found I really want to really fine tune the accuracy of this and the cutting quality of it. So I like just to hog out this area first with a 1/4" bit. It's also, I have, if we open it up, you'll see over here that I have a pocket allowance of 0.02. That's this space around the outside edge. So that creates that little remnant there that I'll then trim back with another bit. Let's go ahead and preview this for a minute. Clean up, I'm going to reset this. I also have this preview only toolpath, which is just basically cutting out what the parts look like. So those are my 4 parts. The 1/4" router bit that is going to come in and rough out the finger joints like that. I've also added my dados in there. And you'll notice that in the drawing over here, the dados on the short ends can run all the way through because that dado is then hidden with this finger right here that covers that up. However, the dados right here on these ends, or the long ends, need to stop short because we don't want those running through because it would be visible on the outside of the box. However, down at the bottom, we do want a couple of them running all the way through because that's where the lid is going to slide out. So let's preview those. You can see here how they extend all the way through there, but they're stopped on the other 3 areas. Also, this piece is trimmed down to the width of that so the lid can slide over that area. That's the lid end. So I create those 2 toolpaths together because they both use a 1/4" end mill, so I can save and run those at the same time. Having run those, I will next run my 1/8" end mill, and this is a profile cut, so it's just profiling around it, and I'm just trimming that around. I'm using an 1/8" end mill here because I want a nice tight 1/16" radius on the inside for my fingers. I'm also going to set up this 1/8" end mill. If you look right here, I have an allowance offset of a negative 0.0025. It's about half the thickness of a sheet of paper. And if we zoom in, you'll see it here. You can see there it's overcutting a little bit. I need to do a little bit of allowance like that in order for these fingers to fit together. If you cut them exactly to spec, they will likely not fit together smoothly. They'll be too tight. So you always have to add a little bit of allowance. Same thing applies within the box gadget itself. You can add allowance there as well. Now this looks like a really small amount, but I'll show you it actually adds up. If we look at these joints right here, it adds that 0.0025 to each side of the joint itself and each side of the finger. So it actually ends up doubling and quadrupling. So our total allowance, or if you think of it as total wiggle room, ends up being 0.01. That's about 2 thicknesses of a sheet of paper. Now, somewhere between 0.01 and 0.02 is usually a comfortable slip fit. I'm a little on the tighter side here, and I found that I actually had to sand these tenons or these fingers a little bit for the fit together, but I preferred a snugger fit. I didn't want to have to hammer them together, so I didn't have to hammer them. I was able to slide them together, but I didn't want any rattle in them. I wanted a nice snug fit. So that's what worked for this one. You'll find that depending on your bit, your machine, material, your cutting direction, it will vary a little bit. And that's why I usually will just set it up to be slightly on the snug side, depending on what kind of project I'm doing. I built these boxes for storage boxes, where actually I either nail these together with a pneumatic nailer, or I screw them together and glue them. In those cases, I may have a much looser fit. But for this one being made out of solid wood, I wanted a nice snug fit. So that's what I ended up with. So when the 1/8 inch bit is run, it will then trim that corner out and make it that tight radius like that. The last toolpath is the nail holes. So I pre-drill those as well. And that's it for the tool paths for these parts. It works out pretty well. It's not a lot of setup. And the finished parts, it's repeatable. I've did numerous boxes in this approach. I've used this jig even for creating other size boxes also. So with that, let's hop over and look at some things that I did on the machine setup. So here you can see I'm machining out the pockets for the jig areas for holding the material in place. It's just 4 of them all lined up together. I actually added a piece of MDF to the top of my existing spoil board, screwed it down, and then machined those out with a 1/2 inch bit. Then I added my solid lumber. Now, there's lots of ways to hold this down, but obviously clamps in this situation, you can put clamps along the side if you want, but this technique of hot melt glue has become kind of my go-to technique. I know some people will put tape on the bottom of the board and put CA glue or super glue underneath it, and that's certainly a fine way of doing it. I have found this technique to be my favorite, and it's surprising how well the hot melt glue holds. Now I put tape along the edge of the project itself so the hot melt glue doesn't get into the grain of my finished project. And it tends to peel off or scrape off the MDF jig easily as well. So that's how I set that up. Then, as I mentioned earlier, I start out with a 1/4 inch end mill to pocket out that joint. And then I go back with my 1/8 inch end mill and trim off that 20 thousandths odd amount just to get that nice snug fit. And you can see here on the right how that inside corner is much tighter. Of course, since I'm using an 1/8 inch diameter bit, this creates a 1/16 inch radius on the inside corner. Now I did away with the dog bones because I don't want to use dog bones on this project, but I still need to accommodate the fact that the corner of the tenon needs, or the corner of that finger needs to fit into that inside radius corner. So for that, I picked up a 16th inch radius roundover bit. This happens to be in a Mana. It's called a mini or micro bit. It works really well to create those little teeny roundovers, and you can see on the right side of your screen there that the strategy for this is how those parts then fit together. That gives me kind of that organic rounded shape with all the pieces fitting together. Now this bit, I have had really good success with it. However, that bearing is very tiny, so you can't put a lot of pressure on it because it's kind of fragile, and it's kind of consumable because you put a lot of mileage on that router bit. So I tend to use it until it burns out, and then I typically just replace it. But I've had good luck with this, and I really like it for that little tiny roundover. Next, let's hop back into VCarve, and I'll show you how I created this nifty little thumb pull on the lid. I'm a big fan of repurposing or using the same jig for the entire project. So rather than set up a whole other jig, I actually just created some registration pins inside the existing jig to position my lid material. I also, as you can see here, ran several samples. Now that finger pull is actually a little 3D model right here. And if we look at the 3D view, it's just that little scoop like that. Now that's something that you can create and customize the width or length within VCarve. And here's the trick. Start out in clip art, grab a 3D tab, double click on this one, works fine. There's the 3D tab. I'm going to drag it down here. And let's split this view so you can watch as it happens. So right now the 3D tab is standing proud, of course. I'm going to select that. I'll use the design window for my editing. Now you can rotate it manually using the 9 or the 0 key on your keyboard. Notice that if I select that and I hit the 9 key, that does the trick, or you could use the rotate tool, whichever. Next up is I'm going to decide, how wide, how deep, how long do I want it. So I'm going to go into my set size tool here, and I'm going to unlink that, and I want it to be width is actually the height dimension there. So I'm going to go 0.5 on that, and then 2 inches on that dimension, and click apply. Okay, let's switch that up. Let's go to that direction and 0.5 that direction. There we go. Now it's standing proud, so at this point, let's uncheck the Auto Z, close out of that. Let's go into the component window, and there's my circular tab. Let's open that up. First thing to do is let's put it to subtract. And that matches that shape. And then the height, I'm going to round that off at a 1.15, and that mimics what I already have. So that's a simple way of creating this shape. And then within the Toolpath setup, let's take and rotate that. I don't actually need that one, so let's delete it. I also inside here create this preview cutout so that I could just trim out that piece like that. So I'm kind of just dealing with my top material for illustration purposes. I also have my registration pins already programmed in there. You can see how they are here on the left side as well as the picture. So I've got those all programmed in. And then I'm using an 1/8 inch bit to rough it out. So let's preview that. That roughs it out, and then the finishing toolpath to finish it off. And it's really that simple. It creates a nice little 3D finger pull on any project, and you can set it up whatever size, width, height, and depth you want. Once I had all the parts made, I pre-finished them with a spray-on lacquer, and then pre-drilled for the nails, the copper nails, so it wouldn't split out with an 1/8 inch bit, and then drove the copper nails in on the ends. Well, the final part of this project is the foam cutting. So let's take a look at what I did for this particular project. Top over to VCarve again. So I'm still in my same VCarve file. This is just another sheet that I set up. If you looked at the list of sheets, I've got a foam cutting sheet set up. And much like I did with the lid cutting sheet, I'm using the same identical registration pins just to keep things simple. I brought in a picture of my tool and traced it using Vectric tracing. I actually did this manually, and I traced out one for the blade and one section for the handle and one for a finger pull, because each of those are going to be at a different depth. I then set up toolpaths for each of those, and the blade one being first. Again, let's take this preview and trim out that section. There we go. There's our basic block of foam. And for the blade pocket, that's going a little under a 1/2 inch deep. So that's the blade pocket. And then the handle is going a little deeper. So that goes down like that. And then I've got a finger pocket. And it's pretty straightforward. Now I'm going to cover the bits and the feeds and speeds here in a little bit, but I just wanted to show you this first just to give you the basic lay of the land here in VCarve, how everything is set up. Again, it's pretty straightforward. My feeds and speeds on here are comparable to what I would use slightly on the slower side for wood. I'm cutting a little more aggressive on the depth. My RPMs are slightly slower than I typically would use with this particular tool. As you can see there, I've got an 18,000. Your machine, you may be able to even run slower. I've got a feed rate of 150 and a plunge of 100. and I'm using a 5/16 inch end mill for this. It worked out fine for this particular setup, but let's hop back and look at some of the other parameters of setting up and cutting foam. So to start out, to show you a bit of the setup, I used a little piece of plywood, aligned that with the existing registration pins on the jig, added some tape to that piece of plywood as well as some tape to the bottom of the foam, and then used CA to hold it in place, and it does a nice job. Now, a couple of things to consider when you're foam cutting. First off, thing to remember is use a fresh, sharp bit. In this case, I'm just using a straight 5/16 inch diameter bit. You could go with other diameters depending on your project. This is a brand new bit. It's razor sharp, and it did a nice job of removing the foam. The second thing of equal importance is use conventional cutting. There's a temptation to use climb cutting thinking you get less chipping like you do in wood, but actually you get a ratty or rough edge if you use climb cut. So use conventional cutting. These two items alone will greatly improve your results. The third item, which is also important, is that denser foams cut more easily. So the denser the foam, the stiffer it is, the more easily it's going to cut. There are a wide variety of foams in the market, just like wood. There's a whole lot of wood out there, types of wood. There's a whole lot of foam. And some of the really soft foam that's used in things like upholstery. It's a polyurethane foam, and it's actually just too soft to cut. But if you move to a denser foam, like a tool foam made for tool cutouts like this product here or something similar, it'll cut much easier. Reducing your RPMs to reduce melting. Some foams you may, if you're running your RPMs too high, you may create some melting on the plastic. So reducing your RPMs will also help. And of course, test cutting is always important. Get an understanding of what's capable with your machine, your foam that you're using, and your particular router bit. Now, there are some really great videos online. You'll come across people who do this professionally. Again, like I said, I just wanted to provide a very simple boiled down method. And I've watched some of those in the past, and I've run some tests, but I thought, you know what, I'm going to run some new tests just for this presentation. And so I went out and set it up a grid, and I used 4 different kinds of foams. Now, the bottom one in the front here is what is called just a closed cell packing foam. You're going to find this packed with machinery, with products coming from Amazon. It's a very common closed celled foam. And you can cut it, but it's not very dense, so it doesn't create a very clean cut. Next up is a tool insert foam, and that's what I use for my project. It's also very similar to the closed cell foam. It is a closed cell foam. It's a little denser, so it cuts a little cleaner. And then if you move into what's called cross-linked polyethylene foam, these foams are very flexible, quite dense, but they're still flexible and soft. They cut really nice, as you can see in the back too there. They're available in different colors. However, they're quite pricey compared to the standard closed-celled foam. So it all depends on what you're planning on using it for. Next up is I lined up 5 different kinds of bits for this setup. I used a straight bit on the first section, a compression bit on the second, a down cut, an up cut, and a low up helical cutting bit on the last one. Frankly, the results were very similar between all of them. Again, they were all fresh, sharp bits, so they did a nice job. There wasn't a lot of difference between them. So that's why in the end, for the little bit of foam cutting that I do, I just went with my standard straight bit. Now, the other part of this test that's worth looking at is that I also did a climb and conventional test. And it's pretty obvious if you look at the back row along here that this back row right here was the climb cut, climb cut, climb cut, and climb cut way back here. The further back you get here, of course, you get denser foam, so it's a little cleaner, but climb cut leaves a real ragged edge, so it's a no-go right from the start. But notice the tool foam right along here, this one here, conventional cutting, all 5 different kinds of bits. I got acceptable results from all of those. So that, again, just keeping it simple. If you get into a lot of foam cutting, there are some specialty foam cutting bits out there from different manufacturers which actually have some advantage to using them. But if you're just doing the occasional one, use a nice sharp straight bit and it should be good to go. And that's what I found with this one. I did get some little strips of wood coming off or a little strips of foam coming off as I cut it, but I got good results with this setup. If you're interested in other classes that I teach, webinars, private training, you can find out more at these websites. Thanks for watching.